The ratio of the base to the height to the other base of a trapezoid is 3 to 5 to 9. The area of the trapezoid is 240 meters squared. Find the lengths of the bases and height.
So when they give you the ratio, that means we have a common variable. And our common variable that I'm going to use is 3x to 5x to 9x. And then we're looking at a trapezoid. Look at your formula chart for the trapezoid. The area formula, for me, I'm going to put it all over 2. It says the height times base 1 plus base 2. So it says the base to height and the other base. So this means we have the base here, height here, and the base here. And let's plug them in. We have is equal to, we know the area is 240, so let's put in 240 is equal to. The height is 5x. And then my bases are 3x plus 9x, all divided by 2. So let's do some mental math. What is 3x plus 9x? 12x. What is 12x divided by 2? 6x. What is 6x plus times 5? 30. I feel like I made a mistake there. It should be 60x. Oh yeah, it is 30x. We have 30x squared, because it was x times x, is equal to 240. Now, what is 240 divided by 30? It's kind of like 24 divided by 3. 8. And when I square root this one, it's going to give me 2, 2, and 2. So I have a set of 2. Radical 2. And we have, oh, actually it goes right in here. So we're going to go ahead and use this. So if I take 2 radical 2 times 3, how many is that? 6 radical 2. And if I take 2 radical 2 times 5, how many? 10 radical 2. And then 2 radical 2 times 9 is going to give us 18 radical 2. And if you want to check to see that number is correct, you can replug them in. It'll give you 240. Okay? This is very, very important. Okay, number 7. Nash, go ahead and read number 7.
The apostles of the two similar polygons are in the ratio of 7 to 9. If the area of the smaller polygon is 98 square feet, find the area of the larger polygon.
So our units is what on this one? What's our units? Feet. So I'm going to put feet right here, and I'm also going to put feet squared. So then, if I tell you the apothem, is apothem a side length or the area of something? What is the apothem? It is a side length. So that means that pertains to our feet. So I'm going to write 7 to 9. But since our goal is to find the area, I have to change this dimension. What do I do for both of them? It says square it. So 49 to 81. And yes, the number's kind of big, which is fine. So we have 49 over 81. I might need like 4 minutes. Okay? So then we have, it says a smaller one is 98. Which number is smaller over here? 49, so we have 98 and x. All right, you can choose to be miserable and multiply 90 and 81. I would not do that. I would compare. What is 49 compared to 98? Didn't we double it? Yeah? So then if I take 81 and double it, what do I get? 162. So if you have that method down, you could be less miserable. Otherwise, we can do that elementary math on the side. Okay? So let's go on to number 8. Okay, for number 8, Campbell, let's read.
The ratio of the areas of two similar figures is 9 to 29. If the perimeter of the smaller triangle is 57 inches, find the perimeter of the larger.
So what's our unit on this one? Inches. So I'm going to write inches. And then inches squared. And the reason why I wrote inches squared was they gave us a ratio of the area. So 9 to 25 goes on the bottom. Now, to make our life less miserable, actually it wouldn't matter because we can square root it. If I'm looking for the perimeter, do I write at the end inches squared or just inches? just inches. So that means I need to go backwards. So if it's squared, I need to unsquare it by square rooting the 9, gives me 3. Square root 25 gives me 5, and that's the ratio I'm going to use. So always follow the end result. So the smaller triangle is 57. Top or the bottom? Top, because 3 is smaller than 5. And for this one, is there that shortcut method? 3 can go into 57 how many times? 19. So could we do 19 times 5?
Yes.
I would do 20 times 5 and take away 5, right? If you have that number sense. It's going to give us 90 how many? 95. It would be in inches. So again, you can still cross multiply. It might take you 20 seconds more. All right, number 9. Brady, let's read.
Give the two figures as the right. What is the scale factor?
Did y'all see the grammar error? Given the two, So our scale factor on this one, it says old and new. So we have 2 ways to write out the scale factor. It's either 4 over 9 or 9 over 4. So let's see which one's better. If my result is bigger, should I pick the smaller scale factor? No, it should be the bigger one. 9 over 4 is greater. And then let's go ahead and set up our proportion. So our scale factor is 9 over 4. I'm going to write it over here. Is equal to, they gave us a larger figure as 180. So 180 is going to go where on this one? Top. And then I have x. Again, you may cross multiply, but I see something. I'm going to hide this magical 0. 9 goes into 18 how many times? So it's multiply by 2 and add a 0. So if I multiply that by 2 and add a 0, how many is that? 80. And it says units, so I'm going to say U. You guys okay with that method? If you're comfortable. If not, cross multiply. Okay, Sophie, number 10. Let's read.
The corresponding sides of two similar polygons are 10 centimeters and 25 centimeters. If the area of the smaller polygon is 48 centimeters squared, find the area of the larger polygon.
So what unit are we using on this one? So we're going to write out centimeters and centimeters squared. So they gave us the sides are 10 to 25. 10 to 25. And our end result is the area, so I know I have to square it. Squaring 10 and 25 sounds pretty silly. Let's go ahead and reduce this first. If I reduce 10 to 25, it is 2 to what? 2 to what? 5? So now I can square that and say we have 4 to 25. Use that ratio. 4 over 25 is equal to. So the given 48 centimeters squared, top or the bottom? Top or the bottom? Top, because it's smaller. 4 is smaller than 25. Let's see if we can use that method again. 4 goes into 48 how many? 12. So then 25 times 12. The way I think about this is if I have 12 quarters, how much do I have? $3, right? $3. And I see that as 300 centimeters squared.